Hi everyone! Today I'm going to be going over memory addressing modes. In particular, I will be going over indirect memory addressing. Now let's do a couple of examples with indirect memory addressing. So we do have some variables x, y, and z. X is 0x1, y is 0x2, and z is 0x4. Over here we have the standard form x, y, z, and 2. So let's identify D, Ri, Rp, and S. We know that D is on the outside of the parentheses, RB is Y, RI is Z, and S is R2. So we have to do X plus Y plus Z times 2, which is, if we look at our key, it'd be 0x1 plus 0x2 plus 0x4 times 2, which would become 0x1 plus 0x2 plus 0x8. 0x1 plus 0x2 is 0x3. 0x3 plus 8. 3 plus 8 is 11, and in hex that would translate to B. So this is how we calculate the address. Again, this is our address. Next, we have x and y. Well, we know the first value will be displacement. It's outside of the parentheses. And then our first item inside of parentheses is going to be RB. Then we just do the same formula. It would be x plus y, which becomes 0x1 plus 0x2. And this becomes 0x3. Our address. And you might have seen this a lot in our assembly instructions where you'll see something like 0x4 and then RAX or RDI or whatever register. What you're doing here is you're just adding 4 to the address inside RAX or inside the parentheses here. Finally, we have 1, Z, and 4. We have D on the outside, and then inside here, our RB is unassigned, so there's no RB. Then we have C, which is our index register, and then we have our scale, which is 4. So putting this together would be 1 plus 0x4 times 4. And this would become 1 plus 4 times 4 is 16. In hexadecimal, that's 10 plus 0x10. And this will become 0x11. And then this is our address. All right, thank you for watching, and I hope this video was helpful.